Vertex sort, also called bucket sort, unlike other sorting algorithms, vertex sort does not compare two items. It simply forms groups and then combine them to sort a collection of data. Arrange the data according to the rightmost letter or value, and then combine the group into one. Arrange them again according to the next least significant value. Repeat until we reach the most significant value. For example, for this set of data, first we group by digit 4, that is the rightmost digit, and then put them into 10 different buckets according to the value of rightmost digit. For example, 1560, because rightmost digit is 0, we put into bucket 0, so on for 2150. For 1061, last digit is 1, so we put into bucket 1, so on. After we have put all the values into those 10 buckets, and then we just write down from the first one, bucket 0, bucket 1, according to the order, and write them back into the set. So you can see those data are sorted based on last digit. And then we group by digit number 3. We do the same, and then we write back according to the basket 0, basket 1, so on. So we do this, and then until we reach the most significant value, leftmost digit, and then we're done. Here is erratic sort pseudocode. You can see this method receives the array of data, and then n is number of data. Integer d represents the number of digits for all the values. Outside for loop just controls how many runs of arrangement. So from 1 to 4 for our previous example. And then we initialize the 10 groups to empty at the beginning, and then we initialize a counter for each group to 0. Then in the for loop, just go through the n data to put them into corresponding baskets according to the value of that corresponding digit. And then replace items in the array with all items in group 0, followed by all items in group 1, group 2, so on. We just repeat this until we finish the leftmost digit. So what is the time complexity for erratic sort? Suppose the number of digits in our integers is k is a constant, and then the maximum size of integer is a constant. For a unsigned long integer, which is 32 bits, and then the largest integer will be 10 digits, so the k will be 10. Suppose we want to sort a student ID, and then normally student number is 7 digits, so the k will be 7. So the time complexity will be the two nested for loops, so it's k times n, which is big O n. The reason behind this is that we are not comparing the items with each other. We just looking at digits. Of course, the key size is a factor, but no matter the key value is, key for example is 12 or 20, but still be a linear relationship because k is still a constant number. So the time complexity for erratic sort is big O kn at equivalent to big O n, which is much better than merge sort, quick sort. Why we don't use erratic sort all the time? Because k sometimes may be too large or large enough to make it impractical. For example, suppose we want to order phone books based on name, the last name, first name, address, so on, and then the integer will be too large for us to use erratic sort. Here is the table to show all the sorting algorithms, the worst case and average case time complexity. For bubble sort, selection sort, insertion sort, the worst case, average case, the time complexity is n squared. The merge sort is n log n. The quick sort in average case is n log m, but it has a worst case with n squared. The erratic sort normally for worst case, average case is big O n. The tree sort, heap sort, we are going to learn in course 207. They have time complexity in average case big O n log n, but in worst case, the tree sort is n squared, heap sort is n log n.